Hey everyone, today I'd like to go through the solution to this problem with you guys. We're going to check inside the FE reference manual and make sure we find the appropriate references and just go through the general thought process of how we solve a problem like this. Okay, so firstly it says that a plane stress element is experienced in the stress state shown above. I see some different stresses and shear stresses on the stress element above. It's asking for the rotation necessary to achieve alignment with the principal plane. We have a few angle options and a few directions to choose from. Okay, so now that we're on a clean sheet of paper, first thing it said is that we need to achieve alignment with the principal plane. The principal plane is when we have a zero shear, zero shear on the stress element. That corresponds to the principal plane. Now, if this is x and this is y, when we have a tau xy equal to 0, that's when we have the principal plane. Now, the way we achieve zero shear on the principal plane is we want to rotate the stress element through a certain angle. Once we rotate the stress element, the normal stress and shear stress components will redistribute. And eventually we will reach a certain angle where the shear stress on the stress element is equal to 0, and that's considered to be aligned with the principal plane. The first and most important step in any problem like this is to identify the stress components, sigma x, sigma y, and tau xy. Using these values, we can construct Mohr circle or plug into a relevant formula to find the angle to the principal plane or the principal stresses or anything else that you need. So let's go ahead and identify those. Firstly, this 100 is compressive. That's a sigma x, so negative 100 MPa. Sigma y is a positive 120 MPa. And a tau xy. Tau is considered positive if it causes this right-hand side face to move counterclockwise. You can see that the tau on this face causes the stress element to rotate clockwise. So it's considered a negative. Its magnitude is 90 MPa. Now, let's go ahead and head into the reference. I know that this is a mechanics and material problem because it's dealing with stresses. I know it's related to stress transformation, so Mohr circle is probably going to be relevant for us. Now, as I'm scanning this page, I don't see a formula for this 2phi. That's what we need here. We need to know how much do we rotate our stress element in order to achieve alignment with this horizontal axis so that it has no tau component. There's no formula for 2phi, but visually you can see that if you can construct Mohr circle, you'd be able to find the 2phi. So all we really need is to be able to construct Mohr circle, then we'd be able to find that 2phi value. Now, remember what I said about the tau? If tau is pointing counterclockwise, it's considered positive. So technically, if you want to draw Mohr circle, the x-axis is the sigma axis. The y-axis, the positive y-axis, is pointing downward. And that's the tau, which is pointing counterclockwise, considered positive. Now, Mohr circle, you don't need to get into all the kind of protractor stuff. All you really need to extract things from Mohr circle is this right triangle. So let's go ahead and plot the two relevant points. Sigma x, let's say this is sigma x, tau xy, and what coordinate pair does that correspond to? Negative 100, 90. That corresponds to negative 100, negative 90. Remember, up is negative on Mohr circle, down is positive. If we go ahead and plot our other point, this point is sigma y, negative tau xy. The sigma y is always associated with the negative tau xy. Now, what is the negative of our negative tau xy? It's a positive 90, and our sigma y was 120. If you connect these 2 points, what you get are two right triangles here. And these right triangles, only one of these right triangles is what you need to be able to determine everything that you need to know. You can find the principal stresses from here, or you can find this angle, which is what we're looking for in this problem. This 2 usually is denoted theta p in all the textbooks. That's the angle to the principal plane, and it's doubled. It makes sense because if you observe, the angle between the stresses used to be 90 degrees. Now the angle between the stresses is 180 degrees on Mohr circle. All our angles are doubled on Mohr circle. That's why you get that little a 2 value right here. Now, you know that this, if you isolate just the bottom right triangle, which is this triangle here, you know that the distance of this leg is just half of the distance between the two stresses. The x value here and here, it's 120 plus a negative 120 minus a negative 100. So this total length here corresponds to 220. That's just 120 plus 100. If we cut that in half, 220 over 2 is 110, and that's this leg length over here. We know that we've gone down 90 here, and we know we have to rotate counterclockwise by an angle 2 theta p, which can be found by taking the inverse tangent. The inverse tangent of 90 over 110 is equal to 2 theta p, and we head counterclockwise in order to achieve alignment with that principal plane. So the solution is this. Let's go ahead and plug in that value. That's great, we got it correct. Now if we view this explanation here, you can see that we have a reference to the manual here, page 133. That's where our Mohr circle guidance was located. If you're interested in solving problems like these, you can check out my application in the description. You can use the referral code Engineering Fundamentals to get a month free on subscribing to the application. You can see that here I have a Mohr circle construction. Same kind of idea, right? And we isolate that right triangle to get a 2 theta p. We take the inverse tangent and we get the angle to the principal plane. Now, as a bonus here, you can see that we could also have gotten the principal stresses. The principal stresses are just the stresses which correspond to being on that horizontal axis. I'm going to isolate this so I can show you a few things about Mohr circle. Now, the first thing is that the principal stresses would correspond to this point right here. And if you rotate this point all the way down, it will correspond to this point right here. The radius of Mohr circle could be found by finding the radius of this right triangle. Now, I computed it before. 110 squared plus 90 squared. The square root of that value is 142. So if we went to the sigma average point, this sigma average value is 10 MPa. Now, if we add this radius or subtract the radius, we can find the principal stresses. Sigma average plus the radius corresponds to 10 plus 142. It's approximately 152 MPa. If you take sigma average and subtract off the radius, it's approximately negative 132 MPa. So you could see that if you're able to construct Mohr circle, you can quickly get the answers here. All you need is to isolate this small right triangle and you can have everything that you need. I hope this video was helpful for you. Please like and subscribe if you want to see more content like this. Thanks for watching. Goodbye.